but that corrosion is not a good sign. So I think it's time to replace the motor. I think that's what we're going to do. So last night I noticed the pool was not running. Also some lights that also run off that circuit were not lit. So I went to the breaker and tried to reset the breaker for the pool sub panel, and it immediately tripped. So I knew I have no power to the sub panel here. It's all off right now. And I also noticed that this was the circuit breaker that was tripped, which is the booster pump, which is not the filter pump, but the pop-up cleaning pump. That's this pump. So I've got the top off, and I've got the capacitor out already, but you can see clearly, and this is de-energized. There's no voltage here at all. It's completely off. But this, there's clearly been some heat here, and on the top, right above this. So here we're going to check the capacitor first. It's a 50 microfarad capacitor, and we'll just, first we're going to check for a short. So I've got it on ohms, but not the capacitor setting. So let's see. So clearly not a short across the capacitor. You can actually see it's charging up there. But let's check the capacitance. So we push the capacitance button. Now we're on nanofarad for the scale. It's an auto scale meter. And it's 50.5 microfarad. Exactly what it should be. So, as always, short out the terminals before you check anything. Make sure the capacitor is discharged. This capacitor is fine, regardless of the soot that's clearly on the side from the burning that happened inside the motor circuit. Clearly has been some heat. So there's been a short circuit. I don't quite know what this thing is. Don't quite know what that is. But since the capacitor's good, the next thing to do is check for a short between the 220 volt lines and ground, and see if, now also notice, yeah, there's definitely some leakage going on here and here. So the motor may have seized because of a leak past the seal. So I'm going to take the back off and try and rotate the motor and see if that may be part of it. But I also want to check to see if there's a short to the case, which might have caused all this. So let's get the meter set up. Okay, so I've got my meter set to ohms, and I've got the audible short circuit setting. So if I touch the leads, I'll hear that. So first we're going to go from one of these leads, one lead to here, nothing, and to here, nothing as well. So I don't think there's a short in the pump. What I'm thinking is corrosion on the pump motor due to a seal leakage. So let's see if we can spin the shaft on the back here. Now here's the back off, and that turns just fine. But that corrosion is not a good sign. So I think it's time to replace the motor. I think that's what we're going to do. So here I've released pressure on both pump motors. I think they're independent systems, but we're going to need to take the pump out, which means we need to drain the water out of the pipes. So that's what we're doing. So it's been a while since I've rebuilt a pump, but as I recall, these outer flange bolts have to come out first, and then the inner motor mounts come off after that. We'll see if I'm right. Coming out. There we go. Pumps out. Let's get it over to the workbench. So we got this thing on the workbench, and as I recall, this has to come off before we can take this off. There's a screw in there. I think it's a reverse thread, and that takes this off, and then you can, and then with Allen wrenches, I guess you take that off. Yeah, this comes off first before we can get to these bolts. But I'm also noticing in one direction, I don't know if you can hear that. That's not a good sound. So we might have I think we definitely had a seal failure, but I wonder if the short circuit was caused by water flowing in to the motor. I don't know. Let's keep going. Okay, these Allen screws are 3/32 imperial, not metric. Thing. All right, take that off. Okay. Now we've got to get that screw out to get this impeller off, and then we can take that off. Okay, that screw turned out to be a reverse thread, as I thought. I used a big fat Phillips on it. And let's get that screw out. And once you get the screw out, this has to screw off. I believe it's a regular left-handed or right-handed thread. But you turn that, and this is going to turn, so we have to put a wrench on there to hold the axle. I love my Knipex pliers, but there's nothing like a good old vice grip to just hold something. Rotate this off here. And sometimes you just need a little more convincing with a nice chain wrench. I have two sizes. The smaller one wouldn't go all around the pulley. And the purists out there might say, oh no, you need a strap wrench so you don't mar up the surface. Nope, it didn't need a lot of convincing, and it's loose now. And yes, it is a regular right-hand thread, so lefty loosey on that. And there's my seal. It's clearly worn. Definitely worn. But now we can take these bolts off and take this flange off. Oh boy. Yeah. A lot of corrosion, but I lucked out. The PEM nuts are good. I don't have to replace this, just clean it up. And yeah, there was a lot of leakage going on here. Let's take this off. You know, it does spin freely, but definitely the water, I think the water got into the pump. So now we're down to something we can replace. And I usually go to my local pool supplier, Leslie's usually, see if they have one. I don't know how difficult this one's going to be. I've never had a jacuzzi 1081, but here we go. Let's see what we can find out there.
1 hour later.
Okay, here's the new pump. Should be bolt up compatible. It's definitely longer than the old pump. but I think it'll fit. See how it goes. So looks like it's going to bolt up just fine, but before we can bolt anything up, I have to clean this up, and that seal has to come out. I have to replace it with a new seal. And we'll see how that's done right now. Okay, so we've got the socket here. We need to drive this seal out, and I'm just going to tap on that socket until it comes out. There we go. So that's what the old seal looks like. You can see there's definitely leakage there. That white is water was leaking past the seal, which was causing all of this leakage. All that white is water leakage. You don't want to see any of that. You have to clean that off. But we can flip this around now and put a new seal in place. Now, if you look in there, you can see where there's definitely some rust. So definitely there's water leakage past the seal. We need to clean all that up with some emery cloth. Let's do that. I've got some, looks like 220 grit emery cloth sandpaper. And we're just gonna clean this out best we can. So that seal makes a good, tight, waterproof seal. You don't want anything in between the housing and the seal. There we go. Big chunks are coming out. This is the seal we're going to use. It's a PS1000 pump seal. Should directly replace what I have. So there's the piece that goes and seats in here. And then this piece needs to go on the other side. Okay, so this new seal seats right in here. And the trick here, there's a trick. You don't want it to go in crooked or it will not seal. So the trick is to get the right size socket, exactly the diameter of this flange, and tap it in very gently. If you do that right, you're golden. In order to tap that in perfectly straight, you need a socket that fits just like that. Not smaller, not bigger. This one happens to be what is it, 32 millimeter? And you don't need a socket like that other than for this purpose. So I've bought one and labeled it seat pump seals. So what we're going to do is put it in there as straight as we can, that, and then we're going to tap it with a hammer. Okay, there you go. And here's the final result. You can see that the lip is seated nice and evenly, and we're ready to put this together. So the new seal replaces this on the back of the impeller. And that impeller then sits up against the other half of the pump seal. And this is the sealing surface. So you want to make sure that's absolutely clean, because that's how it's going to seal. So I need to knock that out, put a new one in. Let's go do that. Okay, so we're going to take this old seal half out, and it's not difficult to remove. just sort of peels out. It's held in there by friction. So, see, it's coming out. And there it is. There's the old seal. And what's interesting, I guess, is this is the sealing surface on this side, and it should look like that. So it's definitely worn, and that's why it leaked. Okay, so our new seal just fits right in here. You can just push it in. It seats pretty much like that. It doesn't go much further than that. So that side's ready. This is how the seal works. This is the other half that goes in the housing, and when it mates up, it just meets with a spring tension, and that's how it seals. If you can see that, it can rotate, but this surface seals against that surface. The flange is going to go back on the new motor that way. The impeller goes on this way, and the mating surfaces will meet up, and by spring pressure, when you tighten down on the screw, you'll get a nice seal there. So these are 9/16 bolts, and it's probably better to do it by hand rather than with the DeWalt power ratchet, because you could pull these PEM nuts right out. And now the impeller has to screw on. So that surface mates with the other half of the seal. And this is a regular right-handed thread, so it just threads on. So on this particular motor, you just take these two screws out, back comes off, and you can see right there, I can get a wrench on that and hold it steady. Okay. I got a vice grip on the back of the shaft, and now I can tighten this the rest of the way. Okay, I've got the impeller on nice and tight. Now the screw goes on here, and we know that's a reverse thread. Impeller's on, left-handed screw is threaded in, flange is on nice and solid. We're ready to put this back in. So I haven't screwed this inlet in yet. I just wanted to point out, it's good to replace this O-ring. They get old and brittle, and you want a really good seal against there. So let me see if I've got one. Okay, we got this O-ring and this gasket, brand new gasket here on the flange. We got both of those lubed up and in place. Let's get this thing bolted in. Okay, let's get the bolts in. Okay, so we've got ground 240 volt, 240 volt ground, capacitors in and attached. Everything looking good. Before I put that back on, the motor, I want to make sure I hear a nice motor hum. Okay. Yep. Okay. Sounds good. Let's wrap the motor up. Shut off the valves so we can get the pumps primed. Leaks, full pressure. So I think we're good. That's all I got. Hope this was helpful. Thanks for watching.